Thanks, Peter. So I'm going to take you through a journey that happened over several years from doing the research I would usually do to the formation of what is now a quite successful startup company, and the accidents and serendipitous opportunities along the way, and also the pitfalls and what was done in rather standard ways and what was in non-standard ways. So in the process, hopefully tell you a bit about the way in which one commercializes academic research and the alternative ways in which it can be done. So it started with a PhD proposal, I think around January 2007. A student working with me, Enrique Perez Gonzalez, he was working on a problem in analog to digital converters at the time, which was a really hot topic right before he started his PhD, because there were opposing audio standards. One used the type of ADD converter that he was looking at, and one did not, and there were almost fistfights at conferences between the people from Philips and Sony and the people from Analog Devices and others over the standards. But then the standards didn't get taken, and suddenly he found that he was working on a topic of very little interest. But he was experienced in sound engineering, he knew a lot about the field, and although he wasn't a mixing engineer himself, he had looked at what the mixing engineers were doing while he was doing other things in sound system design. And he thought there's a lot of interesting problems there that people haven't looked at. So he posed the question, could the mixing be done without a human being? Could one create a system that could analyze musical signals, many different signals, where there's different musical instruments on different channels, and determine how they could be combined? Could it emulate the human being as well? That was his suggestion for a PhD, and at the time he thought, no idea if this is a good proposal. The only papers I can see close to this were from 1975, and there doesn't seem to be anyone working on this. My input at the time was really restricted to saying, yes, I think this is a great idea, you're a great person to do it, and run with it. So that was it, but we started to get a few results, and we got a result related to acoustic feedback. And it got picked up by the press. I remember being in my office when the piece appeared on the New Scientist website. Essentially, they have an embargo. So the journalism community all know that the pieces are going to appear. They all get excited about it, but they can't say anything about it and can't do anything about it until a certain time occurs. And so I was in my office at 9 a.m. and looking at the computer, and I see these emails arriving from BBC, Scientific American, Channel 4, ping, 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 and my phone starts ringing at the same time. And they loved the story. We had a way to deal with acoustic feedback that was just part of the research. So we knew early on that we were onto a very exciting topic. It wasn't just good in terms of answering unanswered questions, but it was really good in terms of the potential impact it might have. But at that point, we still weren't thinking of commercializing it. And then this article appeared. It's the editor's column in Sound on Sound, which is the premier trade, not really a trade journal, because it's in any major store, the premier magazine for the sound engineering and music technology community. And it appeared after the research had been going on for a little while. But he said a few interesting things. Among them, Paul White, the editor, said there's no reason why a band, rock band or any type of genre, couldn't do a recording using conventional instrumentation that can be equalized and balanced automatically by advanced digital audio workstation software. And he said a few other things. He said musicians would rather get on with making music than get deep into engineering. So he's saying the same things that we had built our research around, that musicians shouldn't need to be engineers in order to produce good stuff, that the production, many aspects of the production, could be fully automated. But he's saying this as someone representing the industry. and saying, essentially, there is a big market for this and we believe it could be achievable. So we realized the impact is not just big hyped news stories, but the community really wants it. And so we started building a team. One PhD student scratching the surface of the subject is great, and he's doing fantastic work. But it's a whole new field. We're not building it on top of previous academic laboratory research. That hadn't been done either. So we had a lot of research questions we needed to deal with in order to look at the applications and build systems and prototypes on top of that. So lots of master's students, incoming PhD students, undergraduate projects even started contributing to this area of work. And so it went from one student to essentially all the researchers working with me in any aspect, contributing here. And from our first research result, we then built the first proof of concept of the whole idea. And I haven't really said what the idea is yet, so I could give you what's known as the elevator pitch. But I think instead it might be good just to give you an example of one component of the type of thing that we've been building. And hopefully this example should speak for itself. I won't need to talk much over it. It would help if you could see it before. See what's happening. Why don't you see this? Let's try that one. So the idea is that when you go to a live show, regardless of the genre, there is typically a sound engineer there. There might actually be several sound engineers there. And they are listening to the incoming signal and adjusting the levels of all of the incoming signals, the vocalists, the different instruments, every single microphone on stage, every direct input from electric guitars and so on. They're adjusting those levels continually to achieve a nice balanced sound that sounds great for all of the audience. Furthermore, they're adjusting other controls, equalization, modifying the frequency content in the signals, dynamic range compression, changing the range of the loudnesses of each of them, adding distortion, adding other effects, dealing with the reverberation in the environment. Well, how do they do this? They have knowledge of best practices in sound engineering. They have really good ears, listening to everything while it's coming in. They know a bit about the genre, and they know the instrumentation, and they're taking all this information in and deciding how best to adjust the signals. Why not have a signal processing system that reads in all the signals coming in and in real time makes these same decisions based on knowledge of audio production and based on sophisticated signal analysis. Not only could this be done for live sound, but it can be done in post-production. And it can even be done outside of music technology. You could be dealing with the ambient sound, the Foley, special effects, dialogue for film, game, and broadcast content. And that's what we were trying to build, and what is shown here is one of the demonstrators. This whole interface, by the way, is completely unnecessary. It's only just to show what we're doing. We don't need to have an interface to operate it because it's an intelligent system that does its own work. Essentially, all you need is an on button. So what's being shown here is one of the technologies that's just adjusting the levels, and there's no human control whatsoever. The only adjustment of the interface was to turn on and off two components of the system. So that's what we've been doing, that's what we've built the team around, and let's see if I can figure out how to go back. And we showed our first result. Okay, it's appearing on both screens. We showed our first result, and that also got quite a lot of good press. The first automatic mixing system. And there's several stages in turning research into product. So you have research, you have proof of concept, you have demonstrator, you have prototype. And I suppose here, it was still proof of concept. We showed that this could work, and we had a nice way to demonstrate that with an interface and so on. But we didn't show that it could work with all songs, with all genres. We didn't show that it could work with anything from one audio input to 100 audio inputs. And 100 is still a realistic situation. So a lot more work needed to be done. But it got press, and we realized we had a disruptive technology here. The idea is we're not adding a new audio effect. We're not providing another tool for mixing engineers to work with or providing an improvement on an existing technology. Rather, we're creating a technology that revolutionizes the way audio production is done, that allows musicians, for the first time, to create high-quality productions of what they're doing without needing either to be engineers as well as musicians or needing to recruit engineers and have the budget to do so. So, I don't know how much you know about entrepreneurship, but the idea with disruptive technologies is that they have a hard time getting into the marketplace. But once they do get into the marketplace, they have a really quick growth rate and the potential to perform very well and replace the previous technologies. So we knew we had something that commercially had a lot of appeal. And I remember early on, I was giving a talk about the subject, and I said, well, it's a bit like comparing it to the cameras on your phone. And afterwards, the only questions I got were, yeah, about that cameras on the phone thing. And so I used that analogy a second time and a third time, and it really hit on. And I think others, when talking about the technology, still use this. So if you look at a modern digital camera, it's got autofocus, phase scene, motion detection, red eye removal, but a audio recording console has none of this. Whereas a camera can see the mixing console or sound desk is essentially deaf. It doesn't listen to the signals coming in. We're going to change that. And so I built what's known as the elevator pitch around this, which is the type of very quick introduction to the topic that can grab and appeal to anyone you're talking to, and the thing that you can say while going up and down a lift when you just happen to bump into a venture capitalist in the lift. And this does sort of happen. I don't know anyone who's gotten their investment in the lift, but I do know someone who said he got it by bumping into someone in a coffee shop. So also, it's just a good thing to be able to do about whatever you're working on, research as well as when it's being commercialized, to be able to explain it to any audience at any level. So strongly recommend that. And that was our elevator pitch. So, and I pointed out just how radically different modern audio consoles are. They don't have the intelligent features, and hence quality suffers, or you need professionals. So, been going around hyping up the research for a while, and I started getting emails like this one. We were reading the article in New Scientist, interested in learning a little more, or even seeing if there's a way we may be able to find commercial applications. And this is the director of new products at one of the world's biggest, most successful, and most respected mixing console manufacturers. So when the head of buying new technologies and integrating them into products is contacting you, then you know that there's strong commercial appeal. And so we started switching from just trying to create impact wherever it might be, to putting a lot more emphasis on the commercial opportunities, still talking to anyone, anywhere, about what we were doing. Then a few things happened. So I had this brilliant researcher working with me, and the onset of the idea came from him and the early prototypes, but the way it works in academia, no matter how hard you try, no matter what you do, unfortunately, students keep graduating. And I tried and tried, but he was very good, and he graduated on time, and very successfully. He's now product manager. In fact, I think he's been promoted since then at Solid State Logic. I remember him saying he would return back to Mexico, where he's from, unless he happened to find his dream job in the UK. And he found his dream job based on the research. So students move on, great for him, but a bit tricky in commercializing things. Luckily, we had built a team around the technology. We started getting other contributions, and lots of new things coming out of the ideas. Queen Mary Innovation, especially Adam Bacon, who did the introduction to Peter just before, become very supportive of the research, and they put in some money to help us continue to build great demonstrators and prototypes. And then I get a grant from the Royal Academy of Engineering that is focused on turning research into a startup company. The grant is an unusual one because it's saying it's not just supporting commercialization, it's specifically there to support creating a company out of the research. So in other words, if the technology is just licensed, that's good, but that's not really what they want out of the grant. And some excellent researchers start working with me. They're aware of the commercialization activities, and the way in which it works is they can do anything that they want to do, any sort of good research, but if they want to contribute in this area, there are things that we want done, and they get rewarded for the contribution. Or at least that comes slightly later. So then the next thing that happens is a company called Tandem Launch Technologies was visiting Queen Mary, looking at things that they might be interested in turning into a company. So they're a company with an interesting business model where they try and partner with universities and take great technologies and turn it into companies that can then be spun off or make money in their own right or receive new investment. And so they get a stake in this as a major investor in the company. And so they are a venture fund, but they're a venture fund with their own software and hardware engineers. They've got their own lab with soldering iron and 3D printer and so on and so on. And they're doing some application of prototypes while at the same time taking, say, MATLAB code and turning it into a C++ SDK with API. So they are investors, but they do things differently. They happened to be visiting, and I said, oh, these guys are visiting, why don't I show them what I'm working on? And they, of all of the technologies that they saw at Queen Mary and around Europe on that particular trip, this was the only one that they invested in. So we, at that point, then had investment, but it was still early stage. You can't really call it a major company in that very first round of investment. But with these investments and support from Royal Academy of Engineering, we build new demonstrators, we turn it into C++ code, BST plugins, which is the industry standard for audio effects, there are some interesting challenges there. And we essentially make what we've been working on much closer to industry ready. And we get it to the point where we can just show to companies, not just that we have a great idea, but look how close this is to what you want in your product. That's not a requirement when talking to companies, but it certainly helps. So, they provide an investment, but then we have a slight hiccup. Tandem Launch are based in Canada, and for a variety of tax reasons at the time, I'm not sure that this is still the case, but definitely back then, they needed this to be a Canadian company for their business model. And they wanted to put in a major investment, but it absolutely had to be Canadian. Royal Academy of Engineering provide a grant to form a UK company, and they have to go back to the UK Office of Trade and Investment and say, we formed a UK company. Absolutely has to be. Neither of the two could budge. They both wanted to make sure it was a success, so they wanted to find a way for it to work, but they had their minimal constraints that were opposed to each other. The solution that we eventually came up with, which both were okay with, but it meant that a contract that big became a contract that big, was to form two companies. In the UK, Automatic Music Production Systems, which was the title of the grant, and in Canada you can form companies just with a serial number. So our first major company doing this in North America was 835-2593, and the Automatic Music Productions worked with the European market and had a stake in the Canadian one, which meant that if things were successful, both of them were really doing something. It wasn't just a company only in name. It was a company doing something.
Just a quick question, Josh. So, I mean, obviously you're Canadian, is that right?
Sorry?
Are you Canadian?
No.
Right, so why did you not do the US startup rather than the same continent on the Canadian stuff?
Yeah, so...
Just as a brief aside, sorry.
Yeah. First, the music technology industry is of course worldwide, but one of the most important players is the UK. So there's a lot of reason to do it just in the UK, and there's even in the industry companies that I know started in Silicon Valley and moved to the UK because here's where you could really tap into the market. Tandem Launch just happened to be based in Montreal, just happened to come here, so that was not planned at all. You know, ideally, because of where I am, to have started a London-based company at the heart of a lot of what goes on in the music industry would be great. And we had pitched the idea to local investors. We pitched the idea all over the place. But the first one that really bit at it was Tandem Launch. So in an ideal world, you get 2 or 3 investors at the same time who you can then have them compete against each other, or you can have them combine the investment, or you can see who's offering you the best deal. But what happens a lot of the times, and in this case as well, is the interest comes at sort of random times. So we seem to have a lot of interest from one, and then it died down, and so we usually only had one or no offer on the table. By the way, is it okay if I go a couple minutes over? Okay. So once we've done this, we then get a second stage investment. And this is what Tandem Launch were looking for, because this allows a company that they start to graduate, to become something doing its own business in its own right. And based on that, we finally formed what is now known as MixGenius. So, to summarize a few of the interesting things here, there were real challenges due to the fact that I'm an academic, and the work started as academic research, and that is not, there isn't a nice path from academia to industry. Academia, the whole point is usually to work on problems where the answer is unknown, where there isn't a very strong likelihood of success, where it's usually quite far from commercializable. If all of those things weren't the case, if there's a strong likelihood of success but it's really close to commercial, why do it in the academic world? Why not do it directly in industry? So it's high risk. Industry doesn't want to do things high risk. They want it they want, if there's risk at all, it's risk on whether they make a lot of money or a little money. So they want to deal with real world problems with assured solutions. Academia want just new knowledge, new ideas, knowledge creation, and industry wants market validation. So the idea of success and what you're doing is quite different there. Well, there's another point related to that. Academia ends with proof of concept. You've shown that the idea works or could be possible, and that's it. But in industry work, creating product starts with a prototype. And there's a difference between proof of concept and prototype. Prototype is the first version of something that could be sold. Proof of concept just shows it could work. Academia, you want to share the knowledge, give it away, tell everyone, and tell it wide. And the more detail you give away, generally, the better, and you publish it. Industry is very concerned with protecting the intellectual property. You've got a good idea, do not tell people. You patent it, and even if you patent it, which is officially disclosure, there's still a lot of reticence to telling people the fine details. If you read a lot of patents, you find out they are not written like academic papers, and they usually don't. You can't easily read it like an instruction manual and build the same thing based on paper, not generally. Academic work based around grants, so the idea is it's about spending the money. You spend the money well, you've done it well. Industry, it's about making the money, generating the revenue. So these really are very different. But there are some ways to put them together, which I'll get into in just a minute or two. So there are a lot of dilemmas, and there's a really, really good book called The Founder's Dilemma. And if you are starting a high-tech startup, that's the one that I would recommend, where it's based on a couple of decades of research with high-tech startups and goes through all of the questions that will come up, most of which I can check the boxes and say, yeah, these were big questions. So there's the question, do you start a company? I would say yes, but in my case, it was a bit complicated starting two companies. Who are the co-founders? In my case, it was a university, one of the students involved, and the Tandem incubator. Co-founder positions. So we didn't do this very well, but it's important to really nail this down, and yet still leave some space for it to change over time. Who makes the decisions? That needs to be clear very early on, otherwise there will be disagreements that come up. How to divide the equity? Essentially, do it rationally and fair, but there is no right answer whether it should be an equal split or something else, as long as it's a sensible answer. Who and how to hire? Very important to put in the effort to go through a full interview process, because these early hires will shape the company in the years to come. Who to invest and how to raise capital? Like I said, you really want to have multiple options on the table so that you can compare them against each other. And one other point, one of the later dilemmas that occurs is known as the founder versus CEO dilemma. You could also look at it as founders versus investors. So what the company was formed about is quite different sometimes from what it can become. So do expect a battle there. And so I think we followed an alternative route to commercialization. We did a lot of dissemination, a lot of promotion of the research. That generated interest. That got interest from investors. So by talking about the intellectual property, by sharing ideas, you can increase the commercial opportunity. And that's not the standard way things are done. In our case, the assets were the team and the knowledge, and the research was the value. And so by telling people this is how it's done, we weren't giving away the team. And yeah, people could look at what we said and put enough resources on it, they could do it themselves, but it'd be much more cost effective to invest directly. So the unique selling point that we had was the research breakthrough. Do we protect that, like patent it? Okay, good idea. Do we publicize it? In our case, yes, definitely. And that's the route we took, at least in the early days. So there's no single route, but do enjoy the journey. And thanks to a lot of the researchers who contributed, and happy to answer questions.
I gotcha.